Assalamu alaikum wa rahmatullahi wa barakatuh, grade 9. Hello, how are you? Okay, today we're gonna make a revision for quarter 2 for the physics, inshallah. As you know, we have in this quarter 4 lessons. So physics is consists of 4 lessons, okay? Two of these 4 lessons is about acceleration. Okay, and the other 2 is about vectors. Okay, acceleration, here we have the regular acceleration, which is acceleration of any car, acceleration of any object that moving forward or backward. Okay, and the other one is the free fall acceleration. Free fall. And I mean by free fall, throwing object, any object that you threw, when it only affected by the gravity. Okay, so you threw ball, and this ball is falling down to the ground. Okay, and here we have any car, or we have any object that moving in the x direction, or moving forward like this, or backward like this. Okay, and the other part of our curriculum is about vectors. The first session, or the first lesson, is identification, or as like a preparatory part for the vector. What is vector, how you can represent the vector graphically, and the other part about the vector operation. So here we have vector and vector operations. Okay, and here we have regular acceleration, and the second one, the free fall acceleration. So they are 4 lessons. Okay, 4 lessons, 1, 2, 3, 4. Okay, so inshallah we're gonna start with vectors. We're gonna start in this revision with the second part at the beginning, and then we're gonna get back to the acceleration, inshallah. Okay, so why that? Because I think the last part of the vectors we didn't make a good revision for it, or most of you didn't solve a lot of equation or a lot of problems in our class on the vectors. So we're gonna start with the vectors. Okay, so let's write what is vector. As you know before, if you just like to describe any object like car, the same car that only I can draw. Okay, so if you like to describe the motion of this car is moving towards the north, this car is moving towards the south, this car color is red, this car mass is 10 ton, or this car mass is about 100 kilogram. Okay, this car weight is about 150 kilogram, or sorry, 150 newton. This car speed is what? This car. So all what you are trying to describe this car with is called physical quantities. Okay, and as you know before, that we divided these physical quantities into 2 types. The first type was scalar. Second one is vectors. And I know that you know this comparison very well, because you have studied this comparison before in quarter 1. So what I'm gonna take in this quarter, we're gonna dive more in the vectors. Okay, we're gonna leave the scalars and dive more in the properties of these vectors, the characteristics of vectors, what I can do by these vectors. Okay, so but let's make a recap for this revision. Okay, What does it mean by physical quantity or scalar physical quantity? I said before, scalar physical quantity is quantity that describe only the magnitude without describing the direction. Okay, so if you want to describe the speed of this car, so you're gonna say this car speed is 100 kilometer per hour. That's right, and you didn't mention the direction, so because of that it's a scalar. Or if you like to say the distance that this car is covered is about 100 meters, but you didn't said, or you didn't say in which direction. Is it in the north, in the south? Where is the direction? Okay, so whenever you didn't manage, whenever you don't mention the direction, so this one is a scalar. Okay, so scalar only need magnitude. So it's physical quantity. In order to describe it, you need to mention only the magnitude. But in order to mention any vector quantity, you have to mention two things. Number one, magnitude. And number two, direction. So, like what? Like if you like to describe the force affecting this car. If there is someone trying to push this car forward like this, pushing, okay? So I'll say this car is affected by force 100 Newton in the north or in the east. صح? So here you mentioned the direction. So because of that, the force is vector quantity. Okay? So we can mention another vectors like velocity, because velocity is a speed with direction. So if you didn't mention the direction, it calls, or you can call it speed. Like the speed of this car is 100 km per hour. But if you said that the velocity of this airplane or this car is 100 km per hour in the north direction, so this is called velocity. Okay? Or we can also say or mention many another examples. Like what? Okay, just think in anything you don't mention its direction after you mention its magnitude. Just like distance, like length, width, height, okay? Like time, whenever you mention the time, okay? Just like, as I say, the time of this video or the duration of this video is about 1 hour and a half. So after that I didn't mention any direction. I didn't said 1 hour and a half to the north, to the south. So because of that, the time is what? Is a scalar. So speed, distance, time. You can say also mass. The mass of this car is 100 kilogram. So he didn't mention the direction. But here for the vectors, instead of saying the speed, if you mention the direction of this speed, we call it velocity. If you mention the direction of this distance in one direction, we call it displacement. Okay? And we also have another examples like force, like average velocity, like something called acceleration, which is the second part or the first part in our curriculum this year or this quarter is acceleration. So the acceleration is vector. Keep this in your consideration that acceleration is vector, not scalar. Okay? So all of these physical quantity is regarded or considered as vectors, need direction, but these are only scalars. So what I mean by this physical quantity need magnitude. For example, if you are saying that the speed is 100 kilometer, so the magnitude here is 100. This is the number is the magnitude. Okay, so you say for example the distance or the time is 10 hours, so the magnitude of the time is 10 hours. But what here, if we have to say that the velocity is also 100 kilometer, to north or to the north. So this is the magnitude and this is the direction. Okay? And I know before that we were representing the direction not by typing or not by writing that this is to north. In first quarter, we mentioned the direction by signs like positive, negative. So let's repeat it just as a quick recap for this one. We have north, south, east, and west. Okay? And we mentioned before that the north take the positive sign, and south take the negative, east take the positive, and west take the negative sign. Okay, that's great. So you can say instead of 100 kilometers to the north, you can write only just like this, positive 100. And I will know that it's in the north or in the east. But you may say, so how I can differentiate between the north and east? If there any car is moving to the sky, so you know that this car, by saying that this is positive, I mean to the east. Okay? Okay, or we can use the north and south in the any map or any geographic map. Okay, no problem. So let's get to the distance or the displacement. The same, you have to mention the direction of the displacement. And by the way, if you don't remember the difference between the distance and displacement, if you have someone just walk like this to the north 10 meter, and then to the east also another 10 meter, and then get back to the south also 10 meter. So what the distance and what the displacement? So the distance is the actual pass, 10 plus 10 plus 10. So the distance is equal 30 meter. So let's get to the displacement. Displacement is equal from this one to this one, the shortest straight line, or the straight line between the starting point to the ending point. From the starting to the ending point. So starting here, so the direction will be like this. And this is 10, so this is also 10. So I write here 10 meter. But I have to say 10 meter to what? To the east. And as you see, east is taking the positive direction, so we can write here positive. Okay, that's great. All of this information is an old information, or yes, very old information for you. So what's the new? The new is not in the scalar, the new here in the vectors. Okay? So for example, I say that you can represent the symbol of any vector of these vector by bold-faced letter. What I mean by that? If you like to mention the velocity, you can write the velocity as like this. Very bold face. But if you just like to write the speed, it will be also V, but just like this. Italic. This is italic and this is bold. You know, whenever you use the Office or Microsoft Office or PowerPoint, whatever, okay? So if you like to make an important note or an important word, you have to select it and make it in the bold face. So the bold face in your book, whenever you find this symbol in the bold face, that's mean that this is vector, okay? We also have another way to differentiate between vectors and scalar in the writing of their symbols. You can write the vector like this, V, boldface, and above this one is arrow. There is an arrow in above of the symbol. And here we don't write any arrow, okay? So why this arrow? This arrow is represent or mentioning the direction. Not the real direction, but it's mentioning that this quantity is vector. Okay? That's great. What also differentiate, or how we also can differentiate by vectors and the scalar? Also you can differentiate by representing the vector by graphically. What I mean? Any vector, for example, you are saying that this object move upward like this, and then move downward, or move to the right, and move to upward again. Okay, so this representation of these three vectors, okay, is called, or is only for the vectors. You can't do that for the scalars. So the third thing, or the third property we can add, that we can represent the vector graphically. So I write it here. Okay, here's good. We can represent it graphically. خلاص؟ جميل. And this part is the first part we're gonna talk about, or we can dive in it, in how we can represent the vector graphically, and then make a summation for the vector, make a subtraction, make a division, make a multiplication. So this is the next part we're gonna talk about, okay? But this was all about this comparison between the scalar and vector. Okay, so let's get to the second part. We don't need the scalar anymore. Okay, so I just said, since you can represent the vector graphically, so you can make a multiplication, make a summation, make a subtraction, make a division for the vector. Let's start with the summation of vector. Summation of vectors. Summation, adding, okay? So, if you have three vectors like this is the first one, and this second one, and this third one, la. Okay, this third one, no problem. And this is the last one. Okay, and I call this one A, B, C, D. Okay, I tried to make it to make them different from what I draw before in the class, because I get this question many times. They are constant, or the A is always upward and the B is always to the east. No, they are not similar, or they are not constant direction. No, the vector can be in any direction, in any given direction. Okay, so let's get here. So for the first one, vector A and vector B, for example, if he asking about the summation of A plus B, what we can do, I'm gonna say A is this one. You have to know the rule before doing anything. To make summation, you take the head of the first vector with the tail of the second vector. Okay? This is the first step, and then you have to get the resultant. Okay, let's start with this step. Where is the first vector? This one. And where is the second vector? This one. Okay, so this is the first, and this second. Okay? Where is the head of the first vector, and where is the tail of the second vector? This is the tail of the first vector, and this is the head of the first vector. And this is the tail of the second vector, and this is the head of the second vector. So this is the tail, and this is the head. This is the tail, and this is the head. So the rule is saying you have to take the head of the first vector with the tail of the second vector. Where is the head? This one. Where is the tail? This one. You have to merge these points, or you have to attach with these points together, or match this point together. So I write this one at the beginning, okay? And then you have to write the other one, the head of the first vector with the tail of the second vector, like this. Okay? And then you have to draw the resultant. So where is the resultant? The resultant is always between the tail of the first vector to the head of the second vector. So the resultant is just like this. Okay, from the tail to the head, so it's direction like this. This is called the resultant. Okay, that's great. Let's take another example. For example, to take B plus C. Okay, so where is B? B is just like this. Where is C? C is just like this. The head of the first vector with the tail of the second vector like this. And then you get the resultant from the tail of the first vector to the head of the second vector. Like this. So this is the resultant. Okay, so you will find this question in your first quiz. How you can get the resultant? So I'll say resultant, for the resultant, from what? From the tail of the first vector to the head of the second vector. Okay, that's great. This is for the resultant, and this is for the rule of the summation. Okay. Before I go, I have here to say some property, very important property in representation of the vector graphically. If you have a vector, for example, this vector is equal 5. Okay? And another vector in the same direction and also equal 5. So, same direction and also equal 5. Okay, so you have here to write these vectors similarly or very equivalent or at the same length. Because if he's saying we have another vector, its length is 10, so you have to write the vector like this, 10 and this 5 and this 5. So what I mean by that? I mean that we represent the magnitude of the vector by the length of the vector. Okay? So the magnitude, if the magnitude like this was very small, so the length of the vector will be very small. And if the magnitude is very large, so the height or the length of the vector will be very high or very long. Okay? That's great. So we can take other examples, okay? But that's enough for the summation. Let's take the subtraction. I'll just erase. Okay, and I'm not gonna write the subtraction here. I'm gonna write the subtraction here. Okay, so what if he asking about A, okay, minus B? Okay, you have to keep in your consideration that subtraction is the same like addition. Okay, we use the same rule. What's the same rule? The head of the first vector with the tail of the second vector. Okay, so what's the difference? The difference is only we take the opposite direction of the second one. What I mean by that? I'll say, you know that A minus B is the same just like A plus minus B, or A positive negative B. How this is equal to this? How on earth? Because the minus or the negative direction here is always equal positive times negative. Positive times negative is equal negative. So I didn't make any difference. Positive times negative is equal negative. So this is equal to this. Okay, so we can remove this one and keep with this one. Okay, so you will find that the problem converted from the subtraction into addition. So we can use the rule of addition. The head of the first vector, yalla, let's try to draw the first vector, the A, plus negative B. But as you see here, we don't have the negative B, we only have the B. How you can get the negative B? So I'll write it here. Negative B is equal, it is the same like B, but in the opposite direction. So I write it as it is. It's the same like B, but in opposite direction. Okay, so let's get the negative A. Okay, I know that we don't use it right now, or we are not gonna use it right now, but let's get the opposite of all of these vectors. So negative a is equal the same like a, so the same just like a parallel lines but in opposite direction. Because sometimes I saw some students are making the negative a like this. Okay, no, that's another vector, that's not in opposite direction. So to make it in the opposite direction, you have to make it parallel to each other but in the other direction. So this is called negative a. Okay, but this one is wrong. So let's get negative c, parallel but in the opposite direction. Negative c. Negative d, parallel but in the opposite direction. Negative d. So let's keep solving our problem. So a plus negative b. So where is negative b? This one. And I said before, to make a summation, head of the first vector, this is the head. With the tail of the second vector, this is the tail. So this is the tail of the second one. And then you have to get the resultant. The resultant from the tail of the first vector to the head of the second vector. The tail to the head. Or you can say the straight line from the starting point to the ending point, like the displacement. Okay? So this is called the resultant. How the question is coming, or how the question is in this point. How he gonna ask me in this point. Okay, he gonna ask me about the resultant. He's not gonna ask me about these directions or these vectors. He need this one. Okay, this is the resultant. ماشي, or called displacement. طيب هيسأل على ايه؟ So he's gonna ask about two things. Number one, magnitude. Number two, direction. Okay, so how we can get the magnitude? The magnitude, as I said, it's the length. So we have to get the length of this vector. And then the direction is like this, in the east. So the direction, where the direction of the arrow? It means the direction of the arrow. ماشي? Okay, so sometime, okay, he gives you like this one. How I can get this? I'll say two problems here. One of them you have, I think you have solved it many times with me in the board, and this one is a little bit different. Okay, so let's write it right here. If the first vector like this, okay, and second vector was like this, so where is the resultant? The resultant is this one. Okay, and this one was 10 meter and this one was 15. So how we can get the resultant? We use something called Pythagoras theory or Pythagorean theory. ماشي? Okay, so how we can use it? Okay, let's give symbols for each side. This is called, for example, A, and this is called B, and this is called C. We said that C, this one, C is equal A square plus B square. Okay, so what if we just like to get the only C, not the C square? I don't need the square. To get rid of the square, you have to put root, because the root cancels the square. But you can't put the root only here, okay? Because mathematically will be wrong. So if you put the root here, you have to put it also here. خلاص? And the equation will be just like C is equal root A square plus B square. So A squared is equal 10 and b squared is equal 15. So I'm gonna erase this one and write 10 square, and erase this one b and write 15 square. And then you can find the answer by your calculator. Okay, easy? Inshallah, easy. Okay, so I'll say another one. It's a little bit harder, but it's not very hard. Like this one. He said when I draw a plus b, and what if he gave me this one was 15 and this one was 10? How you can get this one? Okay, I'll write the rule. So this one is a, this one is b, and this one is c. Okay, and then c equal root a square plus b square, as we write here. Okay, so but I don't need the c, I need the a. Okay, so we have to get back one step, only one step. I said c square equal a square plus b square, and you just like to get the a. And I said to you before, the unknown that you like to get, or the variable that you like to get, if you like to get the a, leave it in its place and move the other physical quantity to the other side. So I leave the a in its place and gonna move the p to the second place. Okay, and we know, because this one is positive, it's gonna move by the negative sign. So I'll say just like this: a square equal this, for move b to here, so it's gonna be c square minus b square. And because you don't need a square, you just need a, not a square, so you can remove the square and put root here and root here. Okay, let me check بقى if it appear in the mobile. يعني it's not appear. Okay, I'll write it again. Okay, no problem. Okay. I'll write it here again because I know the upper part isn't appear in the video. So again, c square is equal a square plus b square, and we need to get the a. So the a, leave it as it is, leave it in its place, and move the b to the other side. So c square minus, because this one with positive, get to the other side with negative, c square minus b square is equal a square. And because you don't need the a square, you only like to get the a, so you can put here root and put here root. This root cancels the square, so the equation will be like this. So the a is equal c square 15 square minus b square 10 square, and that's it. You can write it in your calculator and get the a. خلاص? And that was all about Pythagoras or Pythagorean theory. And you have to know this. You have to know. But here we have a very important condition to use. I mean, you can't use Pythagoras or Pythagorean theory if the triangle wasn't right angle. So just look here. This triangle with right angle. This is 90 degree. And this triangle with right angle 90 degree. So what if the triangle was like this? Okay, and the resultant was like this. So here, can we use Pythagoras? If I get to you and say that this is 10 and this is 15, you can get this one? No, you can't. I'll say how you can get, but in the at the end of this video, not right now. Okay, but right now you have to know that whenever you use Pythagorean theory, you have to have a right triangle. Triangle have 90 degree. Okay? That was amazing. Okay. Okay, I forget that this part is not appear. I'll write this triangle again. I made a triangle like this, and the resultant is like this. So I said this triangle you can't use the Pythagoras theory or the Pythagorean theory because this triangle is not right angle. Okay. Now let's get back to some higher or advanced problems. It's not very advanced, but يعني a little bit advanced from the other one. What if he gave me a vector like this, and another vector like this, and vector like this? A, B, C, D. And said to me, get back 2a plus 2b. Okay, and then plus c and minus d. Okay, so let's make it easier. We have 2a, we have a. So what is the 2a? 2a is the same like this one, but double the length, but in the same direction. So this is 2a. 2b, we have b. Easily you can draw the 2b like this. So this length is double this length. So if this one was 5, for example, so this one is 10. And this is called 2b. Okay, these numbers are examples, not real number, okay? So, if this b, so this one is 2b, okay? So now we have 2a and 2b. Then c is here. No change in c. So let's get negative d or minus d. We have d. I said to get the minus of any vector, you have to make another vector parallel to the old one, but in the opposite direction. So this is the negative d. Let's join all of these vectors together. 2a like this. Plus 2b, this one, head of the first vector with the tail of the second vector, head وtail. بعد كده c like this. Okay, then we have negative d. This is negative d. So negative d is like this. Okay, and then we get the resultant. The resultant from this point to this point. Okay, easy. So don't get astonished from the length of the problem. Okay, it's so easy. It's a very simple idea. Okay, that's nice. Let's get to another idea. As we said, that he's gonna ask you about two things. The first one was the magnitude. So we have vector like this, okay, and another vector like this. So the resultant like this, and the magnitude, you get this c by Pythagorean. You said the c equal root a square plus b square. This is a and this is b, right? Right. Okay, so next one, the direction of the vector. What's the direction of the vector? Okay, if the vector was just like this, in the direction of the x, or in the direction of the y like this. So you can say negative or positive. Here this is positive and this is negative, this is positive and this is negative, okay? But if the direction of the vector was northern east, or between the north and the east, like this one, how I can represent the direction? Here I don't like you to write it's northern east, but I need the direction by the angle to get the angle, okay? So let's call this angle theta, okay? You can call it whatever you like. You can say theta, gamma, alpha, whatever you like, you can call it, okay? But we're gonna call it theta because we used to call it theta. Then, how we can get this angle? If I have this one was 10, and this one, for example, was 12, okay? Here we have to know something called trigonometric functions, which is number 1, sine theta, number 2, cosine theta, and number 3, tan theta. The sine is equal what? Before I'm saying, or before I say equal what, you have to know the names of these sides, okay? What I mean by the names. The theta, the side opposite to the theta, opposite to means in the face of, in front of. So the side in front of theta, this side يعني, is called opposite. So I'll call it opposite. So that means the opposite is equal 12, okay? Then we have another two sides, this one and this one, okay? So the side in front of the right angle, or sometimes I say the long side, is called hypotenuse. This is the long one, so this is called hypotenuse. Okay, so we have opposite and hypotenuse. And the side adjacent to the theta, or near to the theta, is called adjacent. So this one is called adjacent. So here we have opposite, adjacent, hypotenuse. Okay, so a lot of you, I think, is have just like a miss or can differentiate between the adjacent and the hypotenuse. So by easy word, the adjacent is always shorter than the hypotenuse. So you will find two sides near to the theta. This one and this one, this one and this one. So the taller one is the hypotenuse and the shorter one is the adjacent. And also, if you like to make sure of your answer, you will always find the hypotenuse in front of the right angle. This is the right angle. This is the 90 angle. So the hypotenuse in the opposite of the right angle. Okay. So let's get here back. What does it mean by sine theta? Sine is equal opposite over hypotenuse. So opposite 12 over hypotenuse, this one, يعني B over C. Opposite over hypotenuse. Let's get to the cosine. Cosine is equal adjacent over hypotenuse. Adjacent over hypotenuse. And the last one, and I think the most important one, but all of them are important, but the most important one, I'll write it here to be here to be more clear, tan theta. And tan theta is equal the opposite divided the adjacent. Opposite divided the adjacent. Okay, so don't forget what we were doing. We just were like to get the direction. We were just like to know the theta. We have to know this angle to solve the problem, because in the problem he always say get the magnitude, which is the length of the hypotenuse or the length of the resultant vector, and number two he's saying or he's asking about the direction, and I said the direction here is theta or the angle. Okay, So how you can get the angle theta? You have to ask yourself what I have. So you have what? You have the opposite is equal 12, and here you have the adjacent is equal 10. That's right. So which one of these trigonometric function has the opposite and the adjacent? You'll find the tan has the opposite and the adjacent, okay? So the opposite is equal what? The opposite is equal 12. So this one is 12. And the adjacent is 10. Okay? So that means what? That means, I write here, okay? That means from this one, that tan theta is equal 12 over 10. 12 over 10. Okay, let's get theta. How we can get this theta? So, is it tan theta or theta? It's only theta. So we don't like to get tan theta. We have to get theta only. So we have to get rid from this tan. How we can get rid from this tan? You can move it to the other side like this. So theta will be equal tan to the other side, means 1 over tan, which is we can write it as a tan minus 1, or tan inverse 12 over 10. And you can make it by your calculator. The tan, to write the tan in your calculator, is shift tan. Shift tan, okay? Do not forget and just type as a tan 12 over 10. The answer will be wrong. You have to write shift tan 12 over 10. Okay? And to get the answer, or to get this angle. Okay? So, ماشي. I don't know the angle right now, but you can make it by your calculator. Shift tan 12 over 10. So what else? What else we need? So right now we get the hypotenuse or the resultant, and we get the angle. And the question has ended right it is, or right now. Let's get to the next idea. I have to just explain the whole lesson, inshallah, the whole 2 lessons, and then we can solve the sheets, or we can solve the problems after the total explanation. Okay. Another idea, it's different, and it's another problems, or another type of problems. He say, or you know, if you have just like a table like this, okay, table like this, okay, and there is someone trying to push this table from here, okay, so he pushing like this, okay, and another one, okay, is pushing like this. Upward, and this to the east. So can you tell me where is the resultant, or how can this table move? So the answer, the table will move like this, in between the two. So why is that? Why it's gonna be in between both of them? Because if you like to make it as a problem, the first vector is just like this. The second vector just like this. So the resultant will be in between. Okay? Or you can make it right like this. You can the first vector was like this one, and second vector like this. Okay, so, or you can get this one and put it here, so the resultant right here. Okay, so what I mean by that, I mean that any vector with angle like this one came from 2 other vectors. So if the vector was with angle like this. So that means that it's get from the x and get also from the y. Okay? This is the origin of this vector. And in this question, he always asks about the x component and the y component, or asking about the origin of the vector. So, where is the x component? To get the x component, you have to make a perpendicular line to the x. So, this part is called x component. And this part, if you also make a perpendicular line to the y, this part is called y component. Okay? So how we can get this one and you can get this one? By knowing what? By knowing that this vector, for example, is equal 100. Okay? And knowing that this vector is walking with angle, for example, 40. So the theta is equal 40. But you don't have, or you don't know the x equal what and the y equal what. Okay? So, how you can get this part? You have to ask yourself the same question. What I have and what I need to get. Okay? So, what do you have in this right angle? You have what? You have the hypotenuse. This called the hypotenuse. Hypotenuse. Okay? And what do you like to get? You like to get the adjacent. This part is called adjacent because you like to get the x, which is the adjacent. Okay? And this part is called, or this side is called opposite. Okay? So, from the sine and the cosine that I erased before, sine was equal opposite over hypotenuse. Cosine was equal adjacent over hypotenuse. So, as you see, I have the hypotenuse only and I need to get the adjacent. Which one of them contain hypotenuse and adjacent? Hypotenuse and adjacent. Hypotenuse and adjacent. So this is the cosine. Cosine theta is equal adjacent over hypotenuse. I'll write it down here. Okay, cosine theta equal adjacent over hypotenuse. Okay, don't forget the aim. We just like to get the x, this part. Okay, the theta is equal 40, so we can erase the theta and write 40. And the hypotenuse is equal 100, so we can erase the hypotenuse and write 100. So that to get the x, which is adjacent, what we need, the x. How we can get the x? So the x, this part is equal to this one times this one. So I'll say x equal cosine 40 times 100. Okay? And you have to make it by your calculator. You will find the magnitude. For example, you will find it equal 15, it equal 80, it equal 90. Okay? So this part is equal cosine 40 times 100. Okay? And here we have an important question. Have I do the same steps each time? Whenever I like to get the x, I have to write this is hypotenuse and this is the opposite and what I have and what I have to do? No. You can get the x by saying, okay, cosine the angle, cosine 40 times the vector is equal 100. So whenever you like to get the x, say only cosine the vector, or cosine, sorry, the angle, times the vector. Okay? The other part, how you can get the y, this part. Okay? Ask yourself the same question. What I have, you like to get the y, which is equal this part. So y component is equal this part. So you just like to get the opposite. And you also have, or you only have the hypotenuse. Tani, you only have the hypotenuse and you like to get the opposite because the opposite is equal to the y component. ماشي? So hypotenuse and the opposite. where we have hypotenuse and opposite, hypotenuse and opposite, hypotenuse and opposite, sine, sine. So I'll write here sine theta is equal opposite over hypotenuse. Okay, I just like to get the opposite. So this is the y. The theta is equal 40. So we can erase the theta and put 40. Hypotenuse, where is hypotenuse? This is hypotenuse. Hypotenuse is equal 100. So I erase hypotenuse and write 100. Okay? So how we can get the y? This one. Y will be sine 40 times the vector sine 40 times 100. Okay? And make it by your calculator. You will find a number, okay? Easy number, no problem in this. And I'll say also, whenever you like to get the y component, which is this part, you will use the sine. And whenever you like to get this part, you will use the cosine. Okay? So you can make it clear without estimating what I need. Should I use the sine? Should I use the cosine? No. Whenever you like to get the x, use the cosine. Whenever you like to get the y, use the sine. Okay? So sine what or cosine what? Sine the angle theta times the vector, which is 100 here. Okay? Okay, so I'll say another example, and you have to answer it without doing all of this effort. Okay? Okay. The example is saying, okay, someone was driving a car to the south, okay, and then he turned it to the east like this, and he will say get the direction and get the magnitude. So where is the resultant? The resultant from this point to this point. Okay? Sorry, the question here is to get x and y components. Okay, so where is the x and y component? And where is my vector? So the vector is here. This is the resultant, okay? Okay, so this resultant with which vector, or sorry, with which angle? So he have to say that this vector, for example, 50, and the angle is about مثلا نقول المرة دي 70 or 60. Okay? So how we can get the x component and the y component? I said to get the x, you have to make a perpendicular line to the x-axis. This is x-axis. And to get the y, you have to make a perpendicular line to the y-axis. Where is the y أصلا? This is the y-axis. Right? This is the y, and this is the x-axis. So where is the y component? Perpendicular line to the y. Okay? So this is the y, and this is the x. And you don't forget that this part equal this part. So this is also the y component. So by getting this part, you can get this part. Okay, that's fine. So now, how we can get the x and y? As we said, x component is always equal, x is equal cosine the angle is equal 60 times the vector. Where is the vector? Vector this one is equal can 50. So cosine the angle times the vector. And by this equation you get this part. And how we can get this part? The y component is always equal sine the angle sine 60 times what? The vector. The vector is equal 50. This one. Okay, very simple steps. Not all of these steps you have to know where is the sine, where is the cosine, should I use the sine, should I use the cosine? No, x-axis with cosine and y-axis you have to get it by the sine. Sine the angle times the vector. Okay, fine? Okay, so let's get back to the last idea. Okay, and then we're gonna solve inshallah the revision sheet in details. We can we can solve it online يعني مش, we don't have to solve it in the board. I'll say, or I will decide that inshallah the best decision to solve it in the board or on the word or on the مثلا lab or كده on the screen. يلا. Last idea. Bismillah. I said before, what if you have vector like this and then like this? Okay, so this vector or these two vectors are not perpendicular. They don't have right angle, so the resultant will be like this. Okay, so we don't have here right angle to make مثلا a square or root a square plus b square. So this is a, this is b, and this is c. Could we say c equal root a square plus b square? No, wrong, because this is not right angle. Okay, so right now what should we do? Okay, we have right now to make right angle for ourselves. We make by ourselves right angle. So how you can make right angle for this one? Okay, I'll say this is a complete question before we make anything. He said that this one is this angle is with this vector is 25 and this vector is 40. Okay, and this angle, he said that this angle is مثلا 50. Okay, yeah. How you can make the right decision, or how you can make right angle to get this hypotenuse? Okay, so to make right angle, I'll make a vector like this, another vector like this. This is the x and this is the y. Okay, but to get this vector, to get the hypotenuse, you have to know the x component and you have to know the y component, or this is our x component and this is the y component. So let's start with the y component, this part. Okay, if this part was straight like this. Yalla, step by step. This one, if we made straight line like this, okay, we will say that this part is called the y component. Y component of which vector? Of this vector. So why you said that this is the y component of this vector? Because if you make a right angle here, so this is the y component. Okay, this is the y component of this one, and this one is equal this one, so this is the y component also. So to find this one, you will see what y component by sine or cosine by sine. So y equal sine the angle which is 50 times the vector. Vector is equal 25 times 25. So like this we get this part. Okay, so we still have to get the other part, this part. Okay, this part consists of two parts. The first part, this length is equal this one. This is 40, so this is also 40. Okay? What about this part? Is this part considered the x component of this one? Yes. How you can get that this part is x component? Because if I made a perpendicular line to the x, you will find that this part is the x component. So let's get this part, x component. How we can get the x component? We always say x equal cosine theta 50 times the vector 25. Okay? Cosine 50 times 25. Okay? You can make it by your calculator like this. For example, you get any number, cosine 50 times 25, say you get 10. And here we have 40, but this number aren't exact number. So this part is 10 and this part is 40. So the total part or the total x is equal 10 plus this part is 40. So the total part is equal 50. خلاص? And this part is equal what? This part is equal what? This part is equal sine 50 times 25. Say that this part is equal 30. I don't have calculator right now, so say it's equal 30 by doing this this equation in your calculator. So this part is 50 and this part is 30. Now you can get this part, which is the hypotenuse. How we can get it? You know the hypotenuse C is equal root the x or root the a, because this is a okay, this is the a and the b. No, let's say root the x squared, this part square, plus root this part square. So x square plus y square, and we get the x, total x is equal 50. So c is equal root 50 square plus y squared, this part equal 30 square. And by doing this in your calculator, you can get the c. I know this idea is a little bit harder. We can make another problem to make it easier, inshallah, and it's the last part in our curriculum. Okay, so let's take another example. If you didn't understand from the first, inshallah, you're gonna understand from the second. Okay. For example, he gave me a vector or airplane or car moving like this. Okay, and he said that this car or this airplane make an angle about 30 with the ground. If this is the ground, yeah, اللي هي ال x-axis. Okay, and then this one turned like this. Make another angle 20. Okay, so then he said what's the resultant and what's its direction. Let's get to the resultant. What is the resultant? He started from this point and ended at this point, right? So the resultant from here to this point, to here. Okay, this is the resultant. But this triangle is not right angle, so we can't get this one. Okay? And he has to say that this one is equal, for example, 40, and this one is equal 50. This vector equal 40, and this vector is equal 50. So how we can get this one, hypotenuse? Since you don't have right angle, make the right angle by yourself. So, and make the resultant, this is the resultant that you like to get, the hypotenuse of this right angle. Again, if you don't have right angle, make the right angle by yourself. And make the hypotenuse that you want, or the resultant that you want to get, make it the hypotenuse of the new right triangle that you're gonna do. So what is the right triangle that you're gonna do? I make the triangle like this. And if you notice, or if you just see, you will find I make the hypotenuse that I just like to get, the resultant of the vector that I like to get, I make it the hypotenuse of the new triangle that I made. Okay? Anyway. خلاص? But you have to know, in order to get this hypotenuse, which is called, for example, C, you have to get the A and B. Because as you know, C is equal root A square plus B square. So right now we have to get the A, all this part, and B, all this part. How we can get the A? If you notice that this part is the x component of first vector, vector 40. This is the x component of vector 40. And this part, okay, equal this part, or this part, sorry, not equal this part. The x component of this part, which is this, equal the x component here. So by getting the x component of this vector, you can get this part, second x. Okay? Okay, and so let's get the x. If this part is equal, I'll say the x is always equal cosine angle, which is equal 30, times what? Times the vector, times 40. This is this part, from this to this. يلا. The other part, from this part to this part, هجيب ال x component of this vector, اللي هو البارت دوت. And this part is equal this part. So this part is equal x or another x. So this is x1, this is x2 مثلا. X is equal cosine angle equal 20 times the vector 50. Okay? And then get the summation back between this part and this part. Okay, يعني for example, I don't know the exact number because I don't have calculator right now. But if this part, for example, was 30 and this part was 35, this part was 35, so the total x is equal 65. Okay, so I'll say here we get the A, which is the total x, is equal 65 square. Then we have to get the B, this part. How we can get this part? You will find that this part is consist of two parts. The first part, this one, and the second part, this part. So why I'm saying that? Because this vector, the y component of this vector, this part, and this part is equal to this part. So if you get the y component, you can get this one. يلا. How you can get the y component? Okay, I'll say sine the angle times the vector. So this part is equal sine 30, the angle, times the vector is 40, times 40. Yalla, let's get this part, the smaller one. Okay, this part is equal what? This part is the y component of this vector. Y component of this vector. Okay, so how we can get the y component? I'll say sine the angle, which is 20, times the vector is equal 50. Okay? After you get the answer of this one, and you get the answer of this one, make a summation between them, and by make this summation, you can get the y component. Okay, so this part is equal, for example, I don't say the right answer or the exact answer. If this was 20 and this was 30, so the y component or the y, the total y is equal what? 30 plus 20 is equal 50. So the b, the total b is equal cam 50. So I write here 50 square. And then make it by your calculator, root 65 square plus 50 square, and you will find the answer, the hypotenuse or the vector that you want to get. Okay? Inshallah, we're gonna solve many questions, or most, يعني half or most of the questions of the revision sheet in this part. and we will be inshallah completed the vector and vector operation. Thank you.